Alrighty, welcome everybody to all things Azure and Azure OpenAI for game development. PC Mag said this is one of the only gaming sessions at Build, so we felt a little pressure to make it fun being the only gaming session. So we thought about like a choose your own adventure game show hosting type thing, but instead we opted for 64 slides. You're gonna get 64, now we got demos, we got slides. We're really excited to be talking about our end-to-end vision for gaming at Azure. My name is Jon Kefaloukos. I'm a strategic partnerships director leading our relationships with our largest gaming customers, AAAs in the United States, working with Uthappa and Dan and a huge team at home. Big shout out to the entire team to build out our gaming at Azure vision and strategy for Azure and Azure OpenAI for game development. So really excited to talk through our top use cases today over the next 45 minutes. This is probably like 3 or 4 hours worth of content. We got one session for gaming, so we're gonna cram a lot within a short period of time. We're really excited to talk through it. Thank you so much everyone for joining. All right, so here's our agenda. Here's what we're gonna be talking through today. We're gonna walk through our end-to-end vision, our gaming at Azure vision for end-to-end game development in Azure. And then we're gonna talk through really our top 4 use cases: game development and build farms, basically studio in the cloud, game server and game services hosting in Azure and Azure Kubernetes, Azure OpenAI Service and Azure AI Studio, and then we'll wrap up with build, player, and game live ops and data analytics with Microsoft Fabric. If you guys have been here all week, you've heard about a lot of the Microsoft services that we're gonna talk about today, but we're really wrapping those all around in game development scenarios and really excited to dig in. Appreciate y'all coming in and showing up, and for everyone that's watching online. Starting with our highest level, you've seen this slide a million times this week, I'm sure, but we're driven by our North Star in our Gaming at Azure team, which is to empower every person, every organization on the planet to achieve more. From our lens, it's empowering every game developer around the planet to achieve more. And this is important to us, right? It's helping to get rid of the crunch culture that exists in game development. For anyone that works in game development, you know how difficult crunch is, how hard it is to ship a game. And we really do feel that with this kind of end-to-end vision, we are empowering people. We are restoring work-life balance. And on the right side, you'll see something that I think is an important kind of diagram, right? It lays out the fact that Microsoft, compared to any tech company in the world, probably has the largest wingspan of any technology company. You heard Satya say it in his keynote, but from infrastructure to data services, sprinkle AI services, to of course security, robust security, modern work and business applications to help you collaborate and get things done. There is this vision where you could do and achieve end-to-end game development and simplify what is already a heavily complex scenario. Game development is hard, we all know that, and get game developers back to doing what they want to do, which is building great games, building great features, and getting the technology, the infrastructure, the IT engineering out of the way. That's what we're going to talk about today. So at its highest level, our kind of ethos for our Gaming at Azure vision and strategy is really marked by the fact that we're very fortunate. We have a massive Xbox organization of over 40 studios now with Activision Blizzard King. And the majority of them, almost all of them, are using Azure for all things game development, from builds to services and servers and live ops and data and analytics. Azure truly is battle tested by games like Minecraft and Gears of War and Halo and Forza, and of course our third-party customers as well that are using Azure that we support on a day-to-day basis. So ultimately you have best-in-class infrastructure with Azure, first in global availability, leader in cloud and AI developer services with Azure, but all of that is battle-tested courtesy of Xbox and our xCloud and Xbox Vision. And we'll talk a little bit about Xbox services today. Mostly we're gonna be talking about Azure natively and Azure native services, because this is Microsoft Build. But we did want to, I think we'd be remiss to not cover Azure PlayFab. So for those, actually quick show of hands in the room, how many people have heard of PlayFab here? Raise your hand if you've heard of PlayFab. All right, I see like 30%. Okay, awesome. So Azure PlayFab PlayFab was a company we acquired about 5, 6, 7 years ago. PlayFab offers basically an end-to-end suite of managed services for game development and for games, from live ops to multiplayer servers and services to monetization, leaderboards, et cetera, et cetera. So essentially, if you're a brand new game studio, rather than having to build all these things yourself, which takes time and effort and investment, you could use PlayFab as a managed service. And most of these services are running in Azure, and there's obviously a close partnership between our Azure PlayFab organization, which is out of Xbox, and of course our Azure organization under Scott Guthrie. And all of our Xbox game studios, at least the ones you think of, the historic ones, are using Azure PlayFab as well. So I wanted to make sure to cover what Azure PlayFab is, some remarkable services here, not just for games, but media and entertainment as well. A lot of media and entertainment organizations, sports leagues are now looking at PlayFab for gamification and modernization and live ops and telemetry and things like that. Some of the PlayFab innovation, this is an outdated slide as of 2023, but in 2024, we've announced quite a bit. Shout out to CJ Williams, David Syed and team, but really a lot of deeper integration into the Microsoft Cloud and AI ecosystem, particularly with Microsoft Fabric and some of their live ops tooling, Azure Synapse. So again, really good extensibility and a really good story for Azure PlayFab and how it extends into Azure. And I think you're going to see that continue to develop as it extends into Azure AI and Azure OpenAI. Some really exciting things happening with Haiyan Zhang's team and the rest of the PlayFab team. But jumping to the meat of it, so this slide is kind of the slide we're going to refer back to constantly throughout this presentation. This is a one-slide diagram of our gaming at Azure vision. From left to right, essentially, shift left as you're just getting started building a game. You have an empty Perforce repo or GitHub repo, and you're basically starting to build out your CI/CD, your pipeline, your build farms. What does that look like? You can do that natively in Azure. We have a massive partnership with Perforce. And especially for kind of indie or smaller, just getting started game studios, you can basically run Perforce in Azure, or you can run Perforce as IaaS in Azure. Again, far, far left, artifacts, storage, build farms, everything you see in the kind of first box, game development and builds, you can do in Azure. One thing I want to point out too, Cloud Dev Kits. This is a commonly requested item, and excited to share that this is being explored as well, is running Cloud Dev Kits natively in Azure as well. From our Xbox organization. So then you start to move right, and as you think of developing features in game, trying to get more efficient, automation with your game development, you can start to sprinkle in Azure OpenAI Service, Azure AI Services, cognitive speech and cognitive services, for character content dialogue. There's some really rich functionality there to help you build your game, and Azure ML, so essentially AI-infused tools. And then all the way kind of on the right for the player experience, you have game servers, game services, dedicated game servers you can run natively in Azure VMs or Azure Kubernetes or through Azure PlayFab as a managed service for game server hosting. And when you do all of that in one cloud, again, left to right, the most powerful thing is the analytics. The benefit you get from a telemetry analytics pipeline perspective now with Microsoft Fabric and machine learning and Power BI Copilot is rich, from build telemetry, how your build's doing, performing with testing scenarios, to player telemetry, so you can make real-time changes, you can listen to your community. When you kind of run this end-to-end, left-to-right vision for game development in one cloud and in Azure, it's pretty powerful. And a lot of our gaming customers are somewhere on this journey. Some are a little bit further along than others, and it's been a lot of fun working with the AAA game developers around the country to help enable essentially what is this kind of end-to-end vision. So we're going to jump into use cases for all four of those boxes, and we'll refer back to that one singular slide, which again is our gaming at Azure vision. We'll talk about studio in the cloud, game dev in the cloud on the far left, game hosting, game services and game servers, game analytics, and AI in gaming. Of course, would be a Microsoft presentation without talking through how AI is transforming the games industry as well. We're excited to talk about some use cases in AI. So with that, really excited to pass it along and introduce who is one of the masterminds or the mastermind behind that Azure Gaming at Azure vision. He's our lead cloud solutions architect for the gaming vertical, Uthappa. Can we get a round of applause for Uthappa, please? Make some noise. Thank you.
Thanks, Jon. Hey, everybody. I'm a lead solutions architect. As Jon said, we cover some of the one of the largest gaming customers in North America and Europe. So all these are probably from the learnings, and not just from internal studios, but also from external studios. Just a quick question from a show of hands. Can you just point us any game developers in the audience here? Cool.
5 people. Nice.
All right. Okay. So yeah, we'll keep this interactive. We'll keep have some demos as well. And thank you so much for spending your Thursday afternoon here, and we really appreciate you being here. So yeah, we'll cover some of these building blocks. Again, I think that's key here, the building blocks, right? So we are using Azure native services for enabling game developers, development, and then all the capabilities that you saw here. So apart from PlayFab, which is a managed service, all the services are here for general use, right? So we are specializing it, making it more enhanced for game development. Why? Because game development is really, really hard, right? Game development, developers are some of the coolest people out there because they create these amazing games. Think about Minecraft, Forza, Gears of War, Halo. All the Microsoft Studio games have some of these components that are being used today. And think about scalability, right? Now you have games played by millions of players across the globe. with sub-millisecond latency. How do we deliver those games? But let's start from the far left, right? How do you develop those games, right? And how can Azure help in terms of remote game development? So, yeah, this is the one, right?
Yep.
Yeah, so talking about remote game development, it is so hard. Why? Generally, game developers have these powerful GPU-enabled workstations on their desk. They have super fast, performant disk and low-level latency connections to other perforce or other Git, source code systems. Then they also have peripherals attached to them, like think about PAN, right? It's not just for game developers, but also for graphic artists. So how do we enable this on Azure, or for that matter, any cloud, right? So what we did is we worked very, very closely with Azure engineering to build some of these capabilities that are very, very relevant for game developers. So starting with, we are using this service called as Azure Virtual Desktop. Most of you might have heard this. This is probably one of the largest used service post-COVID, because work from home really became a norm, then an exception, right? Azure Virtual Desktop enabled remote development, right, across industries, because we manage the brokering and everything in terms of authentication, authorization, and then you just create those virtual machines really and enable them as virtual desktops, right? The second important aspect of Azure Virtual Desktop is you can run native Windows 11 on Azure, right? With multi-session enabled as well. So now think about it, all the software tools and development kits that are compatible on-prem devices on desk now can be run on Azure as well. So we've used this platform and we enhanced for game development. What are those enhancements? Relative mouse support, right? Which is pretty common and much needed when you, for example, develop or play a game. You can now launch these workstations using GPU drivers that are pre-baked in, right? So we build some accelerators where you have fully baked workstations with gaming tools and softwares with drivers automatically installed so that you can launch these workstations using Azure Virtual Desktop in any part of the world using different regions that we have across the globe, right? Then we also enabled capabilities for optimized 4K streaming and then high fidelity graphics based development and streaming as well. So there are some capabilities that you will see which are part of this GitHub repo. We'll share it as well that enables those capabilities, right? And then game developers often work on multiple projects, right? Azure Virtual Desktop, as you know, can be only assigned to a particular user. So we asked engineering to enable some of these capabilities for assigning multiple projects and desktops for a same developer, right? And then we have a template which includes all these best practices, so you can use that and customize. And then, of course, disk performance, right? So we worked with engineering also to enable enhanced disk performance with Premium SSD V2. Now can go up to like 80,000 IOPS in terms of this performance. And then the last one is a very recent feature, GPU hibernation. Now you can actually hibernate an Azure virtual machine. Even GPU virtual machines, what that means is a developer, when he comes in the morning, the virtual machine is ready almost instantaneously the way on-desk workstations are, okay? All right, these are some of the Azure virtual machines that are today enabled for Azure Virtual Desktop and remote game development. We provide, there's a mix of AMD and NVIDIA-based GPU VMs here, and all these are provided with the drivers. So you don't have to work externally to get the drivers. These are available, and these all can be installed part of the extensions. All right, so now you know how to create a game developer workstation. You can also extend that to different phases of game development, right? So on there you see different source code management systems, whether you can bring Perforce. We have a fully managed Perforce marketplace image published by Perforce on Azure that you can use and build your depots on, or you can have your source code on GitHub or Azure DevOps. You can build the build test farms on Azure using scale sets. If you know Spot VMs, which offer up to 90% off the market list rates. And then you can even build your forms using GitHub Actions or ADO runners, right? And they can all use the common image library, which is the same library that you can use it for game workstations as well as for build test forms. We will all see this in a quick demo as well. It's not moving.
There we go.
All right. There are some of the accelerators that we have enhanced for game build test. For example, 𝗦𝗲𝗀𝗀𝗃𝗃 is a very fast copy tool that we have enhanced for game build copying. It now uses MD5 hash instead of last modified time, because every time you build games, all the files gets updated, at least from the time perspective, but really 99% of the files don't really get updated. So you use that capability. We have a private ADO extension that can interact with Perforce, and when there is a change in Perforce code, it actually spins up the build test pipelines. And we talked about Perforce, and then also Incredibuild, one of our partners, have built capabilities around build test on Azure. So combining Azure Virtual Desktop, the capabilities of game development, and also build test farms, using source code systems across the globe, all using one management console, you are now able to distribute these aspects across the globe, right? So now the developers can be remote, any part of the world, interacting, on Azure. I think, when all those components are on Azure, then the amount of time that you are spending in terms of moving the content across different systems becomes significantly lower. Okay. Now we talked about game development, build test farms. Now let's talk about game services and servers as well. So on Azure, which is a pretty common use case for game publishers to host games, right? You can publish games on Azure virtual machines or on Kubernetes, which is managed, or AKS. And then, as Jon mentioned, PlayFab as well offers game server hosting capabilities. We will concentrate on the first two in our demo as well. This is a high-level architecture on how you can host games today. As you can see, we offer both the platforms as well as PlayFab. We take care of load balancing in terms of managing, opening the firewall ports. So you could have a matchmaker service anywhere, even on-prem or different cloud providers. And then we offer from entry point from DDoS, up to managing the backend connections and database services as well. Right? It's pretty common for our customers to actually expand their on-prem build, game server farm to Azure, and then scale back down because of the pay-as-you-go, capability of you don't need to pre-provision these instances. In terms of game services, this is a pretty common three-tier architecture, right? It's not as complex as game servers, but you still need to make these services globally available. So you see Azure Front Door, API Management, AKS, Azure Functions, Cosmos DB. Some of the services pretty commonly used across the globe. Several industries use these to build those game services architecture. Okay. We'll do a quick demo of some of those capabilities that we talked about. All right, so you might have seen this. This is Azure Portal, right? So I've created a resource group here, and then I've created certain resources. So this is a resource here called as host pool. This is part of Azure Virtual Desktop. And it's a pretty straightforward process to create a host pool. A host pool is created, for example, if you have a set of developers in, say, West US and in East US. So you create two host pools, right? One for each region. You say what virtual machines you need. You select an image, and then you actually bake an image, and then use that image to create these host pool instances or workstations, right? So one important aspect to remember on Azure Virtual Desktop, you don't pay for any of those overlay services, right? You actually pay for the compute, storage, and network, so very similar to an Azure virtual machine. And we don't restrict any virtual machine size or family. You can use any of them underneath Azure Virtual Desktop. So in all aspects of maintenance, management, is just a virtual machine underneath. So here I have a host pool with one virtual machine here, and I've connected to that remotely, and here is mine, and you can see some of the common tools. I have installed a game engine here, and this is all coming through a common template that I've enabled here. If you can see, this is the script that I was showing earlier as well. Some of the tools that I have said that I need to have these in my image, and I'm creating this image on demand, and then I'm building that host pool with those workstations. Right? You can see here, I'm using Chocolatey to install Visual Studio Code, .NET extensions, SDKs, and you can see those all installed within this virtual machine as well automatically. Right? You can see the times to match them, and then if I launch, for example, I've Unreal Engine here, which is one of the common game engine platforms, and I'm seamlessly able to interact with my project, right? With almost no latency or jitterness. And then again, you can just scale this out through automation, through Terraform, through Azure native scripts, and you can scale back down. And you can also set policies such as start on click, so that game developers just have to come in the morning, start on the click button, and then it immediately starts these workstations up. Yeah. And coming back to game builds, right? So this is an example of scale set, where now I've created a scale set with my build test image. I can use Spot VM, so you can see here I have a 100% Spot VM, so I can put a mix as well. Then I can configure it to, let's say 50 VMs, right? So it should immediately start scaling out. And again, once you can automate this as well, part of your build test automation pipeline, so that these are created scaled out and scaled back in almost on an instantaneous fashion. Yeah. So we'll wait for that to come back up, so you can see there already those 50 VMs are being created, right? And then in terms of game server hosting, here is a simple YAML file that I'm using within my AKS, which is essentially Epic Games Lyra server, which is a starter game. I packaged it and put that in an Azure container registry. You can see that image as well. And then I'm exposing on port 7777. And then if I go back to kubectl, and then, so I have 3 nodes, as you can see, and all these nodes have public IP addresses. So this is very typical in a game server hosting deployments, where you'll see public IPs attached to those. So you would connect to the public IPs and the pod's port number, right? So I'm using a command to find that port number. So in this scenario, it is 45291. I'm using one of the pods. And if I head back to my Azure Virtual Desktop, which is a game developer workstation, I've also created or have a game client running there. So I'm just going to connect to one of those ports. There you go. So in a way, it's very seamless manner, able to connect to those game servers that are running within my Kubernetes cluster, and then also play a game from my Azure Virtual Desktop, using simple remote desktop, right? There's no expensive software here to interact, and you can see it. It's pretty seamless as well, and the experience is very realistic too, right? Yep, I think that's about it from my end. Thank you so much, and please feel free to ask any questions after the session. Thank you.
Awesome. Thank you, Uthappa. So shifting gears, we talked on the far left and the far right, essentially, of two use cases so far: game development builds, CI/CD in Azure, and then also game servers and services, connecting close to your player with the global distribution of Azure data centers. Want to shift gears now as we dig through a couple of these slides I think Uthappa shared on just a real life example. So very sad, we actually did this talk at GDC, Game Developers Conference, a couple months ago, and we're very fortunate to have Kate Rayner, CVP, Technical Fellow for the Coalition and Xbox Game Studios, essentially bring this all to life and speak to how the Coalition is essentially achieving this vision. They're maybe one of the closest AAA game titles and game studios that are achieving this kind of end-to-end vision in Azure. This is a quick overview, essentially, of their entire environment at a glance, how they're doing identities, configuration, profile progressions, leagues in Azure, using Azure Kubernetes Services. Orleans is their framework. They obviously leverage Xbox Live. They leverage PlayFab for a few things, as managed services. And on the far left there, you'll see their kind of infrastructure environment from before, which was entirely on-prem and had a lot of challenges with things like giving access to contractors, right? There's contractors all around the world that are working on your game. It's hard to get them secure access to your game, but now that they're using Perforce in Azure and a new kind of Azure-based infrastructure, it's a lot easier and a lot more secure. So shifting gears and moving now to, I think, a topic that I'm sure a lot of y'all were excited for and is certainly the most sexy part of the conversation today. We have AI in gaming. I'm going to pass it over to Dan here in a moment, but of course this is that middle box of how you can basically sprinkle in AI services to help enable this end-to-end vision, to accelerate the game development cycle, automate processes, and create really cool experiences for your gamers and players as well with AI features in the game. Especially with the announcements this week, I think this is a groundbreaking week for game development with what was shared with Copilot plus PCs, 𝗦𝗽𝗲𝗀𝗏 and small language models running locally on your PC now. Essentially gives you the ability to not have to consistently tap into Azure cloud services every time you want to access a large language model. You can do it locally on your machine, which is a lot cheaper and more cost effective. So I think we're about to see an explosion in AI features in games in a really, really exciting way. And we'll talk about some of those use cases today. We're also going to be talking a little bit about building custom copilots today. I want to make sure to clarify, you all know of Copilot in M365 and Power Platform and Windows. You know about our Copilot extensibility story. I'm sure you heard a lot about that this week with Copilot Studio, build your own low-code copilots. Really, we're going to be focusing on the right side today, building custom copilots with Pro Code, Azure AI Studio for leveraging and accessing any models you want, including small language models. And to do that, excited to pass it over to my good friend and colleague here to speak all through Azure and Azure AI for game development, Dan Gartner. He's our Director of Application Innovation for Gaming at Azure. Another round of applause, please, if you could hype it up for Dan.
All right. Woo. All right, thanks everybody. So I'm going to cover how gaming studios are using Azure's AI services to create really awesome experiences. The first thing that I want to mention is just kind of give you an overview of the different AI services in Azure. It's definitely not just Azure OpenAI. There's other models that are available to you. There's a model catalog of over 1,600 models. And so the point is, you can use the model that's best fit for your application, for your game services, and those sorts of things. Some really big announcements this week with the GA of AI Studio and GPT-4o. There's some really powerful things that we could do in the gaming space with those things. I do want to mention a few benefits of running your large language models in Azure. A couple of nice things here is, you can deploy a model as a service in seconds. You've got enterprise-grade security with RBA, role-based access. You can configure your own private networking and those sorts of things. Our customers can leverage their own existing Azure enrollments so that they can take advantage of discounts and those sorts of things as well. This is all managed in your own Azure subscription. The models are not trained on your data unless you're explicitly doing that, right? And there's tons of different models there available for you. So there's a bunch of different interesting use cases. We work with a lot of the biggest game studios out there, and these are some of the use cases that are kind of shuffling to the top that we're seeing. AI for generated social content, empowering artists and game designers and developers to help them use AI to create assets, to write code, those sorts of things. Social media analysis, we're seeing that all over the place. You want to get feedback on your product. You want to kind of capture that feedback, determine if it's positive, negative, those sorts of things. You can easily kind of hook Azure OpenAI into things like Discord and do social media analysis and Twitter and that sort of stuff. We're seeing GPT-powered NPCs, so maybe you want like a rich character in your game and you want to generate dialogue for that NPC using a large language model or a small language model. We're seeing a lot of that as well, and I'm going to work through a demo of that. Image generation, of course, digital asset management, things like text-to-speech, speech-to-text, all that sort of stuff. And then also an AI copilot to assist new players. That's what I'm going to show you a demo of. A player's new to your game. They don't know how to interact with it necessarily. You want to help them along the way. You want to help them along the path. Well, with bring your own data and the RAG pattern, it's really easy to bring in all your documentation and create a custom copilot on top of your game documentation, your game lore, and all that sort of stuff as well to create a custom AI assistant for your games. So I do want to talk for a second on the Copilot stack. Like, this is a developer conference, so what does a developer need to interact with? What do they need to use in order to infuse AI into their games, game services, and apps? And kind of at the top of the stack, it's your apps, it's your stuff, it's your games, it's your backend services, it's your mobile apps. That's the top of the stack. Underneath that layer, you're going to use the different AI orchestration SDKs. You might use LangChain, you might use PromptFlow, you might use Semantic Kernel. There's a few others out there, right? If you're a developer, you're going to want to familiarize yourself with those. And all of those are usable with the different Azure AI models that we've got and the different services. Below that, there's going to be an AI orchestration layer, right? You're going to provide a prompt that's going to control how the LLM or SLM behaves, right? You're going to provide a meta prompt or a system prompt. You can, with OpenAI Assistance API, you can bring in things like function calling. So you can give tools to these models as well. So they can maybe look up data in your on-premises system. They can run code with Code Interpreter. With the RAG pattern, they could do knowledge retrieval. So this is sort of the stack, all built on top of the different foundational models and the infrastructure that we've been talking about in Azure today. Everything is baked in with built-in safety, protecting you from things like prompt injection attacks, content filtering, and all that sort of stuff as well. So this is kind of the developer look of things. Every application that's using these models most likely is going to want to ground it upon your own data, right? And so with Azure AI Studio, it's incredibly easy. It's the easiest thing that I've used or seen our customers use to be able to infuse your own data into these large language models. And so we could do that with Azure AI Studio. I'll walk you through that. But in our scenario, what I want to do is I want to create a custom copilot for my game. I want to bring my own data to that. I want to bring my own custom documentation to that. And so I'm going to walk you through how we can do that super quickly. We're going to do an AI Studio demo. And so what I've built here is I've been working on a game. I'm an indie game dev. And I've got a website with all my documentation. I've got gameplays, FAQs, reviews. I've got a community section, those sorts of things. And I want to help my game developers get up to speed super quickly. And so here I am in the Azure portal. First thing I'm going to do, I'm going to click on my Azure OpenAI resource. You can control a bunch of things here. There's a bunch of knobs and whistles. You can view monitoring. You can view your keys and your endpoints. You can control networking. If I want to configure this to a private network, I can do that. But if I want to build an application with this, I want to create something, I want to infuse an AI experience into my game or my game service, I go to Azure AI Studio. The first thing that I want to show you, it's the model catalog, right? 1,667 different models. So you can bring the model that's purpose fit for your particular use case, right? There's models curated by Azure AI, Hugging Face, Mistral, Cohere, Snowflake. There's all sorts of different models here. If we go to the Microsoft models, Jon mentioned 𝗲𝗲𝗏. If I want to start working with 𝗲𝗲𝗏 and experimenting with it, I click on it. I can immediately start interacting with it right here. So I'm going to ask it a question. Hey, summarize the Battle of Hastings. and it's going to give me a response super quickly. So we can immediately start interacting with any of those models in the model catalog. If I want to deploy this, it's a click. So model as a service, I click on that, I can deploy it. There's a couple different options. It could be a serverless option, or I can deploy it to persistent compute, and I'm off and running. But back to the original demo. I want to build a custom copilot for my game, right? And so I'm using GPT-4 I'm going to ask it a question about my game. What missions are available in Conqueror 1066? That's my game. And this model has a knowledge cutoff date, has no idea about my game, right? It's going to kind of potentially make something up. It's going to try to give its best answer, but the reality is, since it's not been grounded on my data, it can't answer the question. To make this useful, to build a custom copilot for my game, I need to infuse my own data into it. So to do that, it's super easy. You click Add Your Data. You click Add a Data Source. You pick a data source. There's several different options. Azure AI Search, some really good improvements to things like scalability and the size that it can manage this week. You can use data in blob storage. I can pop in a URL, right? And I can index a website super quickly and easily. And so that's what I'm going to do over here. I'm just going to paste in the URL to my website. Right now, I hit next a couple times. It's going to ask me to either configure or select an Azure AI search service. I pick it. It's going to create an index for me. It's going to create a vector search for me. It's going to create an embedding model, right? And I hit next one more time, and I hit create, and it's going to do all that work for me so that I can now bring my own data against this large language model. So it's going to start indexing that for me. It's going to infuse the data. It's going to bring the data into Azure AI Search. Once it's done indexing, it takes a few minutes, but once it's done, when I ask a question about my game, once I've actually infused my own data into it, it should know the answer, right? So there we go. In Conqueror 1066, these are the different missions that you can play. These are the references. It references to the player guide. It knows about my game now. I can ask even like very, very specific questions about controls about the game. How do I view the inventory in Conqueror 1066? And it's going to tell me, this is what you do. You press the I key on your keyboard, and this will open the inventory menu for you, right? So I've created a custom copilot for my game in like 3 minutes. If I want to infuse this into a backend service, here we go, I can click on here, and this is going to show me the code. It's really just, at the end of the day, REST API calls to search, and then it's infusing data into the OpenAI APIs, and we're good to go. If I want to deploy this, if I want to create a Copilot web application, boom, it's a click. I go there, I pop in the name, I hit next, and I'll have a website with my own custom Copilot that I can link my other website to as well. So in like 4 minutes, we were able to create a custom Copilot for our game. And we're just seeing lots of different game studios, I think, starting out with this kind of use case, right? Other things that we talked about, popular in the gaming industry, sentiment detection with OpenAI, with these large language models, small language models. You could do sentiment detection, but you can also do entity extraction, right? And so here's an example. I've created a system prompt. Give me a sentiment and a sentiment score between 0 and 1. But I also, from the comment, I want you to retrieve the platform if they do provide one. So say someone says, oh, your game crashed on my iPhone. I want to be able to pull that out and track that. Here's an example. I'm pasting a review there. It's going to give me a sentiment score. This is positive sentiment. But then maybe I'm sucking in comments or tweets and that sort of thing. And so as an example, if someone said a comment like, it keeps crashing on my Windows XP machine, well, because I crafted my prompt in that way, it's going to do entity extraction. It's extracting the platform in the comment for me. So it's very powerful. It's more than just sentiment detection. It can extract additional information. And all of this based on the prompt that I provided to the model, right? So some very powerful stuff. This is probably the second most common use case that we see in gaming. Lots of different customers are doing that. The last one that I wanted to show, so we announced GPT-4o, or OpenAI did, and then we announced that it's coming to Azure, and it just went GA. it's really fast. It's way faster than like GPT-4 Turbo. So I would say start here, right? But one thing that we've been experimenting with customers is dialogue generation for games. You go up to an NPC, you have a conversation with it. I want to be able to kind of dynamically craft that, right? I want to be able to dynamically craft that based on whatever. Or there's this concept of white box testing, very early stage of games where you're kind of just running around a world. Maybe you just want to infuse some commentary into the early stage characters that you have. That's a great use case for GPT-4o because it's super fast. It's almost like real time, right? So an example of dialogue generation for an NPC, really all I had to do here to create like a dialogue tree or a dynamic dialogue interaction is I created a system message where I'm saying you're an in-game NPC, you've got a brusque tone, you're a bartender at this bar, your tone is gruff and terse. This is a mystery game, right? So we're trying to find out some names of people who poisoned someone. This bartender, we don't want him to give any information unless he's explicitly bribed, right? So I'm imbuing this model with character based on the prompt that I've given it. So if I start having a conversation, say, hi, this is what do you want? I say, I'll have a bourbon. He slides a bourbon to me. Then I kind of ask about the crime that I'm trying to solve. I say, hey, has a fellow named Talon ever come around here? Again, he was a regular, but I don't know nothing about him. And I say, any idea who we met with? And then again, this model has a personality based on the system prompts that I've defined, and then I slide him a $100 bill. And then he's going to take the bribe. So with like 2 paragraphs of a prompt, I have a decently interesting character. And so if you're investigating dialogue for NPCs, I definitely recommend taking a look at GPT-4o. Super fast, great response times, and it's working really well for these use cases too. So those are our 3 demos, right? So those are the different ways that we're seeing how our game studios are infusing AI into their games. Those are kind of the top 3 different scenarios that we're seeing right now. So we're going to shift to game analytics. We have 2 minutes left, and Jon's going to cover that.
I talk fast, as you guys know, so we'll get through it. Round of applause for Dan, though. Interesting stuff with Azure AI, is it not? It used to take days, weeks, months to create characters in games, and it was just done in minutes. Obviously, super simple use cases, but you can just imagine the art of the possible for game development with AI. It's some really exciting stuff. The last and kind of fourth pillar, game analytics and AI. What happens when you do this end-to-end game development in Azure? Your data's in Azure, your builds are in Azure, your services and players and telemetry and pipeline are all in Azure. Well, it provides a ton of rich opportunity for analytics and real-time data, which is the most important thing in game dev, as you all know. Uthappa asked earlier how many of you are game developers, you raise your hand. How many of you are gamers? Raise your hand. Candy Crush counts, Solitaire counts. All right, awesome. Everyone's pretty much a gamer these days. So you all know the power and the importance of community sentiment, feedback, analytics for game development. This was kind of an example of architecture before, a year and a half, 2 years ago. It was very complex. This is an Azure-only view, by the way. So a lot of people don't just do all their game analytics in Azure. They use things like AWS or Snowflake for storage and for other things, or for data lakes. So this is a less complex but still complex view, highly complex. You could simplify it significantly, and ever since Fabric was announced last year, the opportunity that presents to basically use one platform, end to end, with one lake. You guys have heard this story all week long. Being able to virtualize your data live into one lake through Direct Lake and Direct Connect, whether it's from Snowflake or S3. Our expanded partnership with Snowflake this week makes that even more powerful. And then immediately you can use Power BI Copilot to get information and do a ton of really rich stuff with Azure Data Explorer, now real-time analytics, and really, really powerful tools. Again, I could spend a lot of time here, but for sake of time, we'll quickly kind of parse through it. We do have a demo to show what it looks like. Again, another simple demo that Dan's going to walk us through as it relates to data analytics and Power BI.
Super quick demo. There's copilots for everything here. But we've got a Copilot for Power BI. One common use case that we see in gaming is you're collecting a bunch of user telemetry, and you want to create reporting based off of that. So with Power BI, there's a Copilot button. You click on it, and there's going to be a chat box. And basically, you can say, hey, build user analysis reports for me. And it's going to do it. It's going to say, here's some examples of reports that we can create. Are you interested in churn rate? And it's able to kind of infer what reports it can create based on the columns that we have. I want purchase behavior insights, platform usage overview. I click on those, and then I click create, and it makes the report for me, right? And so, in seconds, through the power of Copilot, I'm able to generate powerful reports, and I didn't have to manually create anything. It was just the chat interface here. And then I can filter through everything here. I can say, hey, give me a churn rate report as well, and so, or create a retention analysis report, and it's going to generate that for me. So with text, with prompts, you're able to create these pretty powerful, pretty compelling reports with Power BI Copilot. So that's our last example, but again, we wanted to show the full end-to-end, pretty much everything that we know or we're seeing our customers doing in Azure, and we cover most of the large game studios out there. So with that, I think we're it.
We'll wrap up. Yeah, awesome. Thank you, Dan, for that. Yeah, so again, Microsoft Fabric, this is just Power BI Copilot, but there's so many other rich tools within Fabric that you can leverage as a real-time analytics and end-to-end analytics platform, really for the era of AI. So wrapping up, just of course with a massive thank you to every single one of you for taking the time to join us today. We appreciate it more than you know. It's a fun time to be in game development. If you want access to some of these materials, this is a GitHub repo with basically our presentation materials, additional resources. And then a little bit of a shameless plug here, but we recently announced we're going to be doing an Azure Game Dev Summit on August 14th. If you want, make sure to sign up for our Azure Game Dev Summit. It'll be entirely online. Y'all might raise your hand if you guys know Scott Hanselman. A couple of you guys know Scott. Scott and his team are helping us execute this, which is going to be a ton of fun. So we'll have some really, really cool fireside chats and conversations and topics, really similar to what you heard in the last 45 minutes, but for a few hours for the day for our Azure Game Dev Summit. Again, thank you so much, everyone, for taking the time to join us today. Hope this is interesting. We'll be sticking around if you have any questions or want to meet any of us. And again, thank you for the time.
Thank you.